Hi, Dr. Bai. So, I have a PWM signal going into this. So, that's completely off. And then it ramps up slowly to half speed. And here you can see the waveform. So that's off. And then it goes up to half duty cycle. And then goes back down. So if you look at this waveform here, you can see that when it's on that off period, there's a voltage coming back from the motor. So that's like the inductive, like the back EMF type of thing. But this is only being supplied power on 50% of the cycle. And if I just change this pin here, from that one to this one, is now going in the opposite direction. If I put a load on here, I'm trying to show how it slowly ramps up. And now it's going back down. And it's off. Anyway, this is actually on motor 2 right now. And it's working fine on my board. And it's these two pins, this one and the one across it. If you look here on the board, motor 2 negative and motor 2 positive. And I can go over here and try motor 1. No, motor 0. Let me stop this. Let me find motor 0. Anyway, you don't need to see this. I'm going to keep on testing. But it looks like motor 2 is working for me, and I can do PWM, and I got motor 2 going forward and reverse using an Arduino to supply my square wave. And actually, while we're looking at this, let me show you the signal that I'm supplying, so you can try to replicate it on the Pi. So here's the signal I'm supplying, and let me just put the frequency up. So my frequency is 500 Hertz, and positive width, negative width. Let me put the entire period up as well. So it's a period of 2 milliseconds, and that seems to be doing good. And it goes from 0% duty cycle up to 50%, and it goes up and down, up and down. But I agree with you that it would be a good idea to have a small Arduino type of processor on this board, just to count the ticks from the encoders, because those encoders can spin up to 5,000 times a second, and each time they do 2 cycles, so you need to count 2 edges. So that's 10,000 Hertz you need to sample at, and there's 4 of them, so you need to do 40,000 samples a second. And if you're doing that in an operating system like you have on the Raspberry Pi, it's going to be bogged down. Well, if you have a processor that's doing nothing else other than counting those samples and that type of stuff, that would be a good idea. So a processor like this would be good, or a smaller one as well. And last but not least, I have let me try to stand up here without knocking anything down. I have 9 of these mostly completed. So on these 9, there's no button, no processor, no no power switch, and no battery holder. These white ones are not cleaned yet, so you can see they have residue on the back, and that's something that you should not really have. It's sticky, and it's a not good finish. But if you take a look at these have all been cleaned, and you can touch it without getting stuff all over your hands. So that's why I was saying that, you know, having the IEEE students make these boards may not be the best, because they can't get in there and ultrasonically clean this stuff. You know, here you can look there. There's a bunch of crud there that needs to be cleaned, and on every single joint there's residue. So anyway, I'm gonna finish these all up, and then I'll hand them off to Zia, and Zia can hand them off to Dr. Ahmad. So I basically have 9 here, and then I have another set of 10 to go through. On all these, it's a white PCB with red LEDs, and then red PCB with white LEDs. So cherry and white for all of them. It's the same program that you're going to have, but I'm going to add one more mode, and that mode is just going to be binary counting. So since there's 47 LEDs, no, 38 LEDs, it's going to count. Let's just do a quick Google search. 2 power 38. Oh. Let me try that again. It's going to count up to 1,000 million billion. Wait, 1,000 million. So 270 billion. It'll count from 0 to that number. So I think that'd be a nice mode, and it'll just quickly, you know, do 1, 2, 1, 2, 3, and then count all the way up around. So I should have these done probably by next Monday, I'd imagine. And I'll program a tube of chips, and give you the chips as well, programmed. And I got batteries and stuff. Anyway, I'll keep on testing this, but motor 1 and 2 does work for me. The other thing that you should know about this is that I'm using a 5-volt input here. It should work the same exact thing on 3.3 volts. So if I connect this to 3.3, no, let me plug in the battery. Nope. What's happening here? Ground. Yeah. So that's forward, and this is reverse. That's on motor 2. And then I'll quickly test motor 0 after this, but this video is already too long. Bye.